Hi, I'm Alex Pault with Open Systems Media and Embedded Computing Design, and I'm here at the Things Conference with Luka Mustafa. He's the founder and CEO of IRNAS. Now, Luka, thanks for coming on the stage with us. Where did you get the idea of the company name?
Yeah, thank you very much for inviting me. So IRNAS means Institute for Development of Advanced Applied Systems, but in Slovenian that comes to this letter. So that's pretty much the name and the story about it.
Very cool. Now, you say institute, so did you spin off from a university research effort or something along those lines?
No, so that's completely a story I've created about 6 years ago, as I was coming out of the university, actually, but really wanted to create an environment where we can create new things, create new solutions, and kind of be creative in a business sense of way. So we make real products, real solutions, and not academic in any context. Here and there, we may write a paper or put some information out because we find things interesting.
Now, speaking of products, I see you have a couple here. Why don't you describe what you have for us?
Sure. So we work with a number of partners globally, and we create products for them. I believe you had many of them on the show already. For example, if we start with Rhino trackers, you have seen this earlier today with Smart Parks, and we do the engineering behind the solution to do GPS tracking of rhinos embedded inside their horns. So I can dive a bit deeper into the technical details here. So if we take one that's not fully potted and assembled, we can actually see what's inside. So just to describe this for everyone, we do GPS tracking in the smallest possible form factor. We have a very large GPS antenna because we want good signal quality to minimize the fixed time and get maximal battery life, of course. And then we compress everything around the battery, which is in the center, such that we have the highest density of the device possible. So that really enables us to do a lot of things very well.
Very cool, Luke. Now, I see this larger device. What is this set up for? There's a camera in it as well, it appears.
Indeed, yeah. So this device here is the Aribada Penguin Monitoring Platform. So this is something we built for Aribada, which is doing nature conservation with global partners. So they take this to Antarctica to take photos of penguins. Essentially, that's the story. However, what's actually inside is a Raspberry Pi camera taking photos of penguins, which we've optimized very much to be super power efficient. So that actually means that we can take about 10,000 photos per single charge with this device, and we add solar panels. So power is quite unlimited in that case. But the story we're creating here with the previous guests just before me, Lacuna, is to have also direct connectivity from Antarctica with these devices, so we can get real-time status, like this is the battery, the device is alive, it has so many photos, and so forth.
What are some of the challenges in setting up in a harsh environment a monitoring system like this?
Well, the biggest challenge is how do we reproduce that environment in a lab so we can test continuously and make sure it all works? Because things work if you test them. If you haven't tested, assume it doesn't work, and that's pretty much the story behind all of these things. So we do a lot of cold temperature validation. We run things for longer periods of time, and well, we try to test everything as close to the Antarctica environment we get.
So now, one of the questions that I also asked Lacuna, I'll ask you, how do you deal with security within the system?
Right, so security firstly is important in such case because we want to make sure the data is valid. Although the risk is relatively small, like it's a lot of effort to go to Antarctica and steal a device or do something bad with it. So we assume that's not the attack vector here. But we just need to be able to prove that the data created on the device is actually from that device, from that location, so it's valid. So that's the biggest security risk from this perspective. Obviously, LoRa gives us end-to-end encryption, so that makes things a lot easier. But from the perspective of security, this is the least risky device we probably built. So, yeah, not particularly focused on security in this case.
Now, considering penguin tracking, is this the most unusual application that you've had to deal with?
No, it's one of the fun ones, but we do a lot of more industrial solutions I can't really publicly share at this point in time, but we go very far to cold environments, to underwater, to industrial buildings, tough industrial processes, high voltages, smart grid devices, and so forth.
Now, when you talk about all of these different application areas, are there any application areas that you see as promising that you're not addressing yet, but you see a potential for?
Well, we see a lot of potential specifically with LoRa connectivity in terms of offering out-of-band management, out-of-band control of different devices, and really also like the last resort of communication if all else fails. So from the backup perspective, we haven't seen lots of traction just yet, but particularly for very high-value IoT solutions, this is something very important because you always want to have 3 types of connectivity, as we say. You want local, say Wi-Fi, Bluetooth, or anything that you can do locally, essentially. You want a remote type of connectivity, which may be a mobile network or LoRa, for the matter of fact. And then you want to also have backup connectivity in the best case. So the story we are creating with Lacuna, for example, is, and what that enables us is, we have a device that talks to all the gateways terrestrially, so your normal network, and then you can also have Lacuna connectivity that gives you a bit of backup. So once a day you say, hey, hello, I'm still here. And that's very, very valuable in a lot of industrial scenarios.
Very cool. Now, so Luka, when you think about that whole aspect of creating these solutions, how much engineering support do you find yourself having to provide to your customers to help them integrate your solution into theirs?
Well, the goal is to do the least as possible because we should build solutions in a way where they are intuitive to use and easy to use for everyone. However, that's not very easy to do in a lot of cases where we are exploring what can be done, and we're really at the limits of technology. We're really taking the latest possible solutions, so we end up doing very iterative cycles and just trying to take the smallest possible steps to get the largest addition in features. And when something breaks, we just iterate on the design as much as possible.
Very nice. Now, do you have any tips or advice for our audience before I let you go? Something you'd like to tell about the company that you'd like them to appreciate?
Well, feel free to explore all the open resources. We make a lot of open source designs and put them available, so you can learn from that. But as a general tip, I would say test more than you think you need to test. That's pretty much the story.
And where online do they go to find out all this information?
So everyone can go to IRNAS.eu, and it all points from there on.
Very cool. Thank you so much for taking the time to talk to us today. It's been really interesting, and sky's the limit.
Yeah, thank you very much.